dinosaurs will once again rule the earth.
Here it is. Neutralizing the effects of sulfuric acid. Trihydroxy ionic polymerization. Yes, you never know when you need that. Let's see how you do that. Oh, easy. We have all the supplies here in the Genius Lab. Wait, I need a desk reference though. I forgot how to hydrolyze. Let's see. Ah, there it is. Ah, jeez. Right when I'm in the middle of something, someone always calls. Junior Genius, we solve mysteries. Professor Thomas speaking. Wait, what? Dinosaurs? I thought they were extinct. Yes. Borneo, I know the island. Cloning? Right, I'll get on the phone, contact my assistant Sandra. We'll try and fly out tonight. We'll meet you at the airport, but I'll call you back with a confirmation at this number. Let me call Sandra. Okay. Bye now. Kids, we have our next assignment. It looks like some crazy scientist was cloning genetic DNA from a bone of dinosaurs. He cloned the dinosaurs, and somehow they got escaped. They're running around all over the island and terrifying people in Borneo. We'll have to fly out and try and take care of this mess. Okay, we made it to the top of the site. It's a highly restricted area. So we're going to try and sneak in here without having anyone see us. Here's where we're going. Check it out, it's a dinosaur! I guess not. It looks like it's an excavator. Maybe I need glasses. Hey, is that two dinosaurs over there by the lake? Nope. It looks like it's an excavator and a gravel truck. Man, my eyes. What's up today? man, kids, we finally made it down to the bottom. 2 hours, 15 minutes. So top of the gorge, all the way to the bottom of the lake here. We climbed over rocks. Very, very secluded, isolated, desolated area here. It's a restrictive area. Now, behind me, you see here is the lake. What we're gonna try and do is we're gonna try and take our boat, go out in the lake, and around that corner, there's another small little gorge we'll have to crawl up, climb over that, and then there's gonna be the other lake, and that is supposed to be the breeding ground for the dinosaurs. So first thing we have to do is make sure that this lake is safe. I brought a portable chemistry kit here. We're gonna test the water. So in my pocket here, I concocted something called trihydroxy polymers. Basically like little pieces of candy, almost like rock candy. And basically when you drop in the trihydroxy polymer into brimstone, if it starts bubbling and smoking, you know that that's brimstone for sure. So another fancy word for brimstone, sulfuric acid. You get that on your skin, you get that on your clothes, dangerous because it's gonna burn you. So I think the next thing for us to do is take the polymers, put them in the bottle, see what happens. So let's head on down to the lake. Kids, let's go ahead and get a sample of the water, but be sure that we don't get any of it on our skin. We're gonna lightly skim the top 3 times for our sample. When we do that, you see that we've got a good amount here, and now I've got 5 bits of the polymer here in my hand. Let's go ahead and set it down here in case there's a chemical reaction and see what happens. My safety glasses on here. Whoa! Kids, you see it? Brimstone. Kids, hey, I made it to the other side, but I'm soaking wet and I'm itchy and stuff is stinging. So the soil is made of basalt, which is excess in hydrogen molecules. So if you have acid on your body, you can rub on basalt and it will neutralize the acid. See what I'm doing? So I want to put this on my legs. Much better. Now, we got to climb that gorge. So we got to get started. I know there's dinosaurs up there. We just got to get up to the top of the ridge.
able to make it up the ridge. It's too steep. I'm going to have to take the boat back around to the next ridge and climb up the long way.
Hey, so giving you an update. I made it across the water and I got to that ridge, and that ridge was just unclimbable. It was way too steep. So I had to kind of come back. You can kind of see over that direction there. That's where the ridge is. And we're probably twice as high as that ridge right now, and we need to go another 3 times higher. So we're gonna have to go about 5 times higher and then track down into the gorge canyon there. So I'm exhausted, no water, no food. Probably about 4 hours into the journey, and had to dump my supplies way back over there. It's just too heavy to carry. So I'm gonna rest here for a minute or two, and then I'm gonna head up that direction. You can kind of see, say, some sandy area up there, and then way up there is the top, and then we'll make our way down. So that's the update. Give me a few minutes and we'll start climbing again. Okay, so I made it to the top. Man, that was the hardest thing I've ever done, and you know the professor's pretty hardcore. Take a look at where we just climbed up from. Cliff. Straight up gorge, no ropes. I don't know if you could see that. I had to stop a couple times because I was so scared. Just catch my breath. Now we're in the middle of the jungle, so we're gonna have to fight our way through all this bush and see if we can come out to the clearing where the special lake is, where the dinosaurs breed. Now, I'm starting to understand the whole concept. They're hidden way in here because no human is possibly gonna come in here and find them. So, take a quick break, and then let's keep moving. Kids, hey, we made it here. We're in the dinosaur breeding ground, but you know what? I figured it out. That is not a dinosaur. That's an excavator. And that is not a dinosaur either. That is a gravel truck. Wait, is that the gravel truck and that the excavator, or vice versa? I'm totally confused. Yikes! Oh, let's get out of here. Oh, wait a second, kids. Did I just point, get totally confused, and then say the word yikes? I feel like that's something to do with ACT. Kids, let's get away from the dinosaurs, head back to the Genius Lab, and analyze that a tiny bit further.
Kids, welcome, episode 2, science. Here we are back in the Genius Lab. As you saw in the movie, I looked behind me and I said, yikes, what the heck does that have to do with ACT science? If you remember, a quick review from episode number 1, data. First thing that we're going to do in data is we're going to come over and we're going to go ahead and underline what's important in the question stem. So if we had problem number 1 here is the question stem, we'd simply just underline all the stuff that's important. Stuff that's going to be important would be nouns and verbs, science-oriented things that seem specific and relevant to the particular passage itself. And then we're going to go ahead and underline the location. For example, it would be in figure 1, in table 1, and so forth. All right, step 2 that you learned in episode 1 data is to take 2 hands, and we're going to point. One hand is going to go into the question here, and the other hand is going to go up into the data. So I would have basically one hand here pointing in the question, and one hand over here pointing to make sure that I'm staying on track. The reason we do that and point with 2 hands is because we are going to get lost if we don't. There's lots of information, and some of the words that are important in the question are going to reappear in other areas besides where they tell us to point. So by simply being strict and disciplined, pointing with two hands from what they tell you to do in the underlined portion and the location, you're going to focus in on the area that they tell you to. If that makes any sense. Then after you get done, you're going to hit what's called the set point. You look at all the things and point to all the things in the question stem. Figure 1, pressure, 15 atmospheric pressures, 15 ATMs. All right, then once you get to the set point, you're down here, you pointed, you read everything, and you're in the right area with your hands using a couple different fingers. I've got my finger on 15 and pressure. Then we're going to quickly go ahead and reread the question to make sure you understand what the question is actually asking. From there, instead of going over and looking and trying to analyze the data, simply drop this hand here down into the answer choice and look at your answer first. You're previewing your answer. Then, okay, A tells me this. I look over here. Is that what you see? Instead of focusing over here, trying to interpret and understand the information, simply drop your finger down into the answer choices and try and match where your fingers are to what logically says in the answer choices. Drop and match.
Kids, passage number 3, Yikes video. Here we go. If you look here, activity number 1, that's the italicized stuff. So just above that is going to be the mini introductory paragraph. We're going to focus on the last sentence. Very easy because it's only one sentence on this one. Inside the last sentence, if this were longer, you want to find the major nouns and verbs. So here we see that we have a student performed. That's a noun and verb, but that's pretty general. So now we see we've got 3 activities with a microscope that has 4 objective lenses. All right, 3 activities, 4 objective lenses. All right, now we need to know the difference between the experiments as we go on down through the different experiments. Activity number 1 looks like we've got objective lenses, and there's 4 of them. And then over here it looks like we have the slides, and you can see that we've got 4 lenses here, and we have 4 different slides down over here. As we come into activity 2, we see that we have objective lenses. There's 4 of them. It doesn't say anything about slides. Okay, so let's go back up here in the mini introductory paragraph here. It says 4 slides, okay? And then down over here it says the student was given a slide. All right, so that's the difference between those. Up here in activity 3, we have the aperture, NA, and we're going to do the resolution, and that's confirmed down over here. So what's the difference between the experiments? Here it looks like we've got 4 slides, here probably 1 slide, 4 lenses, 4 lenses, here 4 lenses, 4 lenses, here, different slides, and then over here we're going to calculate M. If we need to know what that is, we'll look up here, finger scanning, R, finger scan if you need that, and NA as well. That's a quick overview of what we see in this particular passage. Now we go right in to the questions. Now this should really take you about 30 seconds. We want to focus our attention on the questions, not so much the details in here. As long as you understand here that we have 4 lenses, and they're going to monkey around with 4 lenses between different things here, calculating stuff out. Kids, that's it for the Genius Map. Let's take a look at the questions. Question number 12, we're going to work together, and I'll have you pause the video before we get the answer. So problem number 12, the first thing that we do is we come over here and read it. It says, if the student had viewed the slide used in activity 2, notice that I'm underlining what's important. Activity 2 is the location. Through a 5th objective lens, and the image size with the objective lens was 30 mm, the M associated with the objective lens would be, all right? Follow along with me. and then we're going to pause the video and have you get the answer. So first thing that we do is we take one finger over here and point to activity 2 in the question. You see it? Then with the other hand, we're going to go ahead and point to activity 2. Where is it? There's activity number 2. I drop my finger down to the 5th lens objective. I come over here in activity 2 and I see where's 5th. The 5th is not there. That means we're going to have to add a 5th lens in here somewhere, okay? Then I take my finger over here and it says that the lens image size was 30, okay? So I go over here and I point to image size, and then now I am going to go ahead and try and find 30. 30 is not in there, so go ahead and put your finger where 30 would be. When we do that, we're going to go ahead and drop our finger in the next associated column, which is M. Go ahead, do that. Put one finger here in the image size where 30 would be, and then match it simply by putting your other finger here. For example, if they told me that the image size was 4, I would go like that, and then I would match my finger over here in this column. Notice that I have 2 fingers. In this case, it would be 4, and the M magnification would be 40. Now, what I'm going to have you do is I'm going to have you walk through, do the same thing here. Go ahead, get one finger on where we said that 30 is, drop your finger, and find out what the M is. Then, when you have your fingers here, you're going to simply drop your finger in the answer choices and then match it up. Go ahead, pause the video here, and we'll take a look at it in a second. All right, we're back again here. So we came over here to activity 2. We found 30th column here. We came down to 30. We saw that there is no 30, so that means our finger is going to have to go between 20 and 40. We drop our finger down over here. That means that our finger, it's going to be between 200 and 400 when we drop our finger over here. H is the correct answer because that's the only one that's going to fall in between 200 and 400. 30 is between 20 and 40, and that means 300 is going to fall in between 2 and 400. H, the correct answer for 12, kids. Kids, on to problem number 13. Here it is down here in the corner. It says, based on the results in activity 2, the combination of which of the following lines and objective lenses will produce the greatest image size. Alright, so first thing we do is come over here, find activity 2, there it is right there, and then we're looking for line and objective size. So I come over here, there's the objective lens, there is the image size and the magnification. Wait, what? Wait, yikes! Kids, I don't know what to do. So here's where we have our fingers like this. We're looking over here. Just take your hand like this, jump on up into the text area. Now we're going to finger scan. Remember, when you point like you're supposed to do with the 2 hands, and you can't derive the right answer by dropping your finger into the answer choice, we're going to have to lift our hands up and finger scan for something that is important. So let's go ahead and do that. Yikes! Okay, wait. Hey, there it is right there. Check it out. Cool. M equals image size divided by the objective size. All right, when we drop down over here, now we know that that's what M stands for. So here's what we have. We have the image size and the magnification. So we need to know what the object size is. When we drop down over here, I don't know what that is because here is 0.7 mm. When I drop down over here, I see I've got mm here. Am I taking this right here, 0.7 mm line viewed through objective lens 1, and switching it into this column? Because if I do, I'm going to get a different answer. So, once again, wait, huh? Yikes! Kids, jump on back up here, and now we finger scan. It says, slide prepared for... Hey, look! Line. The line in the chart is 0.1 millimeters. See that? So when we come back over here in the answer choices, you see that we have 0.7. So, you know, this right here is going to be the line or the object size. Think about what you just did here. look at the chart, and go ahead and drop your finger down into the answer choices, and we'll come up with an answer. Go ahead, pause the video here. We'll come on back in a second. Kids, when you come over here and you do a simple calculation, if we have this right here, this is 0.1 millimeters, which is going to be the length or the object size. Then if we have the image size here, you see that this is 4, and that's going to give you the magnification of 40. So simply, if you want like this, M is 40, image size is 4 divided by 0.1 will give you 40. That's how that all plays out. So as you see here, the image size is the greatest as you increase with the objective lens. Lens 4 is going to give you the highest magnification based on this formula. So when we now drop our fingers down over here, we're going to go ahead and look for the largest objective lens. That gives you lens 4, answer choice D for 13. Problem number 14 up in the top. When viewing slide C in activity 1, students were able to discern 2 distinct lines with how many objectives? All right, so we come over here. We have activity 1. Let's find it. There it is here. We're looking for slide C. Here's the slide, slide C. All right, we've got our fingers here. We drop our finger in the answer choice, and I see we have 1, 2, 3, and 4. Wait, what? I'm confused. Yikes! Lift your hand up, kids. Go over here. We want to try and find what those lines mean. Let's go up here. Lines, lines, lines. See the lines separated, whether they're blurred in image 1. Okay, that makes sense. Oh, here it is. Double lines indicate lines appear separate. When you come over here, we're looking how many distinct lines. Go back up here. Place your fingers on slide C and then come up with the answer. Pause the video here. Come on back with the answer in a moment. Kids, when we come over here, activity number 1, slide C, drop your fingers over here. We finger scan here. Because it's a yikes, we see that when we have the double lines, that means they're separated. Back up here, we see that we have 2 lines, 3 and 4, in objective 1. We drop our fingers here. 2. G is the correct answer for 14. Yikes! Number 15, which of the following equations correctly calculates R in nanometers for objective lens number 2 using the wavelength of 425 nanometers. All right, underline what's important in the question stem, and then now let's go ahead and take a look and see if we can find it. We're looking for R and objective lens 2. Come back up here. It turns into a yikes problem real quick because it doesn't tell you where to go. You see that, kids? Objective lens here, and then I see here's the number 2. You see, I'm just matching it up. I look down over here, I see a bunch of lines. That doesn't help me. Let's go ahead, keep moving. Down over here. Objective lens 2. And now we have image size, but that doesn't match R, and that doesn't match 425 nanometers, because here it's millimeters. You see that? M doesn't help us. Go back up to the top. Finger scan, finger scan, finger scan. I see R here. I see NA here. I feel like I'm getting warm. All right, we come back down over here. And, look, okay, objective lens 2. And now we have NA. All right, still don't really know what I'm doing. So we're trying to calculate our R value, all right? So here's the R value. Here's the NA, and here's objective lens 2. But they're giving us a new 425 nanometer. Yikes! I don't know what that means. Take your hand, jump on up here, and start finger scanning for nanometers. All right? R is the resolution. Da, 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 da. Hey, look at that. Let's write that down. R equals lambda divided by 2 times the NA. All right? Let's go ahead. Take this information take this information in here and go ahead and put it into this chart according to what we have here. Pause the video here. We'll come on back in a moment with the answer. All right, so when we come back over here, we finger scanned and found this formula here. We simply wrote this down, and then now we came back over here and we said we're looking for objective lens number 2. It's right here. And then you see that the and A value is going to be 0.25. So we have R equals lambda divided by, and our lambda here is lambda. If you finger scanned again, you see that the lambda is 550 in this chart here. We're taking 425 and we're going to put that in there. So this is going to be 425 divided by 2 times our NA value, and for here you see our NA value is 0.25. See what I just did? I just kind of finger scanned, I yikesed out, couldn't answer the question, and then I simply grabbed information from finger scanning in the text area. When you look at this, you see the only answer that's going to give you the correct answer is right here, answer choice B for 15, kids. Problem number 16, kids. Another student calculated the R value of a fifth objective lens described in activity number 3. When we did that, we came up with a new R value of 1830. So first thing we want to do is go ahead and point with 2 hands. We come over here and we're going to activity 3. We see that we're looking for the fifth objective. So 1, 2, 3, 4, 5. I just simply draw 5 in here. It's a new lens. All right, and then it tells us that the R value is 1830. All right. So now the 1830 is our R value, which is going to go in this column here. This is a super kind of a similar question you're going to see all the time. You have to kind of estimate and slide in where that 1830 would be. Go ahead, pause the video here. Come on back with the answers in a moment. All right, back again here. We've got lens number 5. I threw it down over here, but if you look at our R value, it's 1830, so we have to try and slide it in between here. They never said it's the fifth one at the end. They said they're just going to add a new one in somewhere in here, so we got to slide it in. When we do that, we have 1830, so we come over to the R value. Where would 18 be? It would be right in here, 1830, so we slide it right in there. And if we slid in between 10 and 0.25, 0.1 and 0.25, the only answer when we come over here and drop our finger in the answer choice is answer choice F. Estimation, kids. And finally, on to practice problem number 17. First thing we're going to do is go ahead and underline what's important in the question stem. Activity 1, activity 2, and how do they differ? And we want to know how activity 1 differs from 2. All right, so right away you see it's a yikes. We're going to need to go in with our hands and start finger scanning for important stuff. So let's go over here, activity 1. I'm going to highlight it. Here it is over here. And activity 2. Now when you look over here, you see that we've got these text box here. It's basically the same thing as what we see in reading, with a topic sentence followed by details. Here in science, this is called a hypothesis. It's nothing more than a glorified topic sentence. And then what's below is going to be results or data to support that topic sentence, or, as I mentioned before, hypothesis. All right? One other thing to keep in mind, since we're dealing with text in experiments, we really need to focus in on what the difference is between the experiments. And what I found is, since there's text, we can use the same tricks that we used when we were in the reading section. So we know flags or flag flip-floppers. But yet, however, although, firstly, lastly, mostly, in conclusion, thus, therefore, and so forth. So I come over here, look for some flags, especially in activity 2 and 3. We're going to see over here it says finally. I highlight that because that's going to be what ended up happening. And next is the procedure. Over here, when you come over here and take a look at this, here I see the word thus. That's a conclusion. Right away, I just identify those things because they're flags. Boing, maybe there's going to be something important that we'll need to help answer the question. All right, then Keeping in mind the big picture of every paragraph will be the topic sentence. In science, it's no different. When we come over here in the topic sentence or hypothesis, we focus on a noun and a verb. Here it is. The students viewed. What'd they view? They viewed 4 slides. And here they are, A, B, C, and D. That's confirmed right down over here under slides. Activity 2, the student was given a prepared slide. See it? There you have it, kids. Pause the video here. Find the answer. We'll come on back in a moment. Kids, the answer, when you look over here, activity 1, hypothesis or topic sentence, 4 slides. And over here, activity 2, a slide. We see that when we drop our finger in the answer choice, A is the correct answer for 17. Kids, remember, in science, you just need to get to the right area. That's it. All you need to do is get there. That means point from here to here and try not to understand too much. Just simply drop your finger in the answer choice and see this needs to Scooby-Doo match where your fingers end up. If you can't answer the question and none of these make sense, we're going to need to lift our hand up, find something here that's a noun or a verb here, and then match it up in the text area here. It will define terms, take that, throw that back into the answer choice to get it. Bottom line is get to the right area by either pointing or when you can't point, yikes, we're going to need to finger scan for a definition. There you have it, kids. Yikes!